Hi, to you all my esteemed viewers, I want to thank you very much for your devotion and support that you've accorded this channel. This channel is about tutoring of construction and surveying concepts. My name is Baxon Ochieng. Welcome to the channel. What we've been doing all along is called estimation of underground water tank. For the past 3 videos, that is what we've been learning through that time. Before we get into that, I want to urge everybody to please make a subscription because it helps us to reach a large number of people, and it also helps that you don't miss any of these upcoming videos, most of which I will assure you, actually all of which I will assure you that are very exciting and you will benefit a lot from learning from them. When we go to from what we need to cover today, we need to cover estimation or measurements for reinforcement bars. So far so good. There are those concrete elements that we've been covering, those that including the strip footing and also strip footing, the concrete slab, the walls, and also the cover slab. For those who are joining us for the first time, please make a recap to the previous videos, which are going to be on this particular playlist. So you can make your reference there and have your background well done for the purpose of catching up with this particular video. Moving on to what we need to cover today is about reinforcement, just as I've said. Reinforcement bars are normally measured in kilograms. That is according to the standard methods of measurements. For you to get the kilograms, there are certain items including the length plus conversion which you need to pay attention to so that you are able to get those particular kgs. Talking of which, there are various elements that we are dealing with here for this particular underground tank, and those elements include the concrete footing. Concrete footing is the part where the cursor is situated or located at the moment, and then the one at the bottom, the entire one, is the concrete base slab. Okay, so from the concrete base slab, then you go to the wall, and then you go to the cover slab. So we need to get the kgs of reinforcement bars in those respective elements. So we'll start with the foundation. This is the foundation layout. Then we have a tank base slab reinforcement details. So on the details, this is where we are going to find where to get the reinforcement bars that we need to measure. And I will also be taking you through how to go about getting the length and converting those items into kgs. So on the side, because we do all our calculations just on the Excel, so you check on the side is where you will do our raw calculations. Now, this is a typical layout that has been designed, and from it, we should be able to get our kgs. So looking at the way the items have been numbered, they are always given according to bar marks, that is. So from these bar marks, you should be able to have it in a procedural order so that we measure them according to certain order. So we'll check item 1. There is one here. Okay. So this is 1. This is 2. Then there is also another one here. Okay, this is 3, this is 6. So all those that are numbered the same, it means they have the same specifications. Okay, so just on a brief, before we go further, I will just make some definitions. So in this form of identification of reinforcement bars, I would like to give what each of them means. So this is the example that I'm going to use. Okay, this one here. So the first 16 stands for number of the bars. So it means there are 16 T10. So the T10 is the diameter of the bar. Okay, so that means there are 10 millimeters bars, but there are 16 of them. Then moving on, 04 is just a bar mark. Okay. 04 is bar mark, while 150 would stand for the spacing. Okay, so 150 stands for the spacing. Let me just make this look better. All right, so just to reiterate what I've said, 16 means the number, T10 is the size or diameter of that particular reinforcement bar. Okay, so in this case we've said, let me just redo that. So 16 is the number of the bars. Okay, 16 is the number of the bars. Then 10, that is here, 10 stands for diameter of the bar. Okay, then 04 stands for the bar mark. So that's a way of marking them. And then 150 here stands for the spacing. Okay, 150 stands for the spacing, while B2 means bottom 2. So at the bottom, at the very first layer of the bars, we have the B1, and then also on the same bottom there is a B2, so on the other direction, because reinforcements are always put in opposite in both directions. So let me say, for example, on the blinding or on the earth surface, the first on the first direction, that is the B1. Okay, also still at the bottom, but then on the opposite direction we have the B2. So like the case in example here, this bar mark 04, it's B2, so it means it's lying on top of the B1. So that is an important point to note. Therefore we'll start. So bar 01 in this case, we are to start our estimation, is a 31 T16. Okay, so on your estimation you will have like T10. Okay, then you will have T12, then you'll have T16. Let's just have those three for now, assuming there are not any other more of them. So at the top here, I will indicate that this is a base slab. Okay, I indicate there that is this the base slab. So bar mark 01 is T16. This is where we have T16. So I will have an equal sign. Okay, I'll have an equal sign, and then this is 31 T16. So I need to get the length of it. Actually, this one is indicated as U bars. Okay, so when you want to note the reinforcement bar, you follow that arrow. The arrow on the bottom of where that where the writing has been done, that one is an arrow which just shows you where the bar is. It's not the actual bar. Okay, so you follow it along until you find where it crosses the reinforcement bar on perpendicular direction. So like in this case, this particular bar, when you follow it properly up to here, you find this point that has been crossed. So it means the reinforcement bar, which has been indicated as the U bar, okay, the 31 T16 is this particular bar, the one that goes this way, then it is turning that way. So this is the U bar that has been referred to in this case. So we need therefore to get the length of that particular bar. All right, so the length of that particular bar is as a result of interpretation from the dimensions. Okay, so on the dimensions, let's see what we have. According to this plan, let me just zoom it in again. According to this plan, let me just see. So according to this plan, it goes this way from here. This is 300, and then it goes up to this point. So let me see if at all there is, so that particular dimension has not been given, okay? And therefore, we'll make an assumption. So we'll assume like it's a half of it, okay? So according to, from the look on naked eye, you can clearly see that from here to here, the distance that is remaining in between, okay, that is from the 300, from here to here, is barely half, but then it's always safer to take a slightly on the higher end. So I will take half of this, half of the 1875. So I'll take, for example, 900, okay? So what I'll do, the 0.9, that is the length on the stretching end, all right? Then I will add the turning point, that is now the U. So how do you get that U? For you to get that U, what you need to consider is this base slab is of what thickness? Okay, what is the thickness of the base slab? So the base slab, from the other details which we had seen, like that is here, sorry, from these details here, the base slab is 150 millimeters. Okay, so what you'll do is that you can assume the entire slab has that has the reinforcement. However much, you should have an allowance of around 50 or 25 millimeters for the cover. But in this case, you make the assumption that for your measurement estimation purposes, you can give an allowance for the entire slab. So that is 0.15. Okay, the 0.9 you will multiply by 2. Okay, because it's on the top and also on the bottom, plus the part that is turning. So this is the length of one piece of reinforcement bar. Then you multiply by the number. The number here is 31. Okay, so you multiply that by 31. So you already have 31 T16. Because you've been given the number, therefore you are not going to use these intervals to calculate the number of bars that you have. Again, you'll use that which you've been given. So that gives us 60.45. So what I normally prefer to do is to get the entire length at first, then we make our conversion into kgs next. Okay, so that is bar mark number 1 is complete. I go to bar mark number, well, there is another bar mark number 1 at this point. So there are 2 of them, and what that means is that I've covered that, then I now go to cover this. So in that case, I should have this 31 multiplied by 2, so that I'm covered for both sides, both cases. Then I go to bar mark number 2. Okay, I can just check if at all there is another bar mark 1 within the particular element, and there isn't, so I proceed. So I move on to bar mark number 2. Bar mark number 2 is here. Okay, it's also another U, and as per the explanation which I gave, follow that particular line. This is the line that is below the marking. Follow it all through. When you reach here, you will find another arrow, like in this case. So this arrow is just a demarcation or annotation arrow, but it's not the reinforcement bar itself. So you follow it again, then the perpendicular bar to it, you can notice there is a difference in thickness of the arrow and also the reinforcement bar. So like in this case, this particular arrow, this is an arrow just for annotation, but then the reinforcement bar itself is perpendicular to it. So you move along it this way up to this point. So this is where we have the reinforcement bar. It's also another U going that way, going this way, and that way. Okay, so that said, we go ahead and find the length of it, so that we are able to make our conversion into kgs after we are done. So what we have here is to get that particular length. So in this length, also here we don't have that dimension given, but the dimension of our slab was 4.5, the entire slab, 4.5. Okay, so the 4.5 we are assuming at this point, okay, because this is option 1. The other option is to rely on what we call the bar bending schedule, which we'll come to look at later on. But for now, we are going to rely on getting the dimensions of the plan. Okay, so my explanation is, in this case, from the entire 4.5, this bit here, we can give it like a quarter of it, okay? A quarter of the, excuse me, a quarter of the entire length. So in this case, a quarter of 4, it's 4.5. So 4.5, so that one goes to around, let's say 1.1. I will take 1.2 for that stretch on the upper side and also the equal length on the lower side. So the size of this bar, mark number 2, the size of it is 16. Okay, so this one also we just do a plus sign into bracket. I've said I'll take 1.2 meters. I'll multiply that by 2. Then I will add also the stretch for the slab, the turning point, the U part. So this is 0.15. Okay, so I have 1.2 by 2 plus 0.15. Okay, then I shouldn't forget to multiply by the number. So bar mark number 2, how many of them are in total? 17. You can see 17 here. So multiply that by 17. Then you check within the slab if at all there is another bar mark number 2. If there isn't, then you're sure it's only 1. Okay, so that one gives us finality for that. I'll just put a tick to make sure that I have all the bars sorted. I proceed to bar number 3 on this particular slab. So at the bar mark number 3, this is the number. It's 14. Okay, T10 03 150 B2. The same concept I've explained. So this is bar mark. The size is 10. You can see that. So it means I should have its calculations under T10 according to the order in which I have organized my work. So in this case, what I'll do, it's the 14 T10. I'll follow this particular arrow. The arrow I will emphasize now and again. The arrow is just for annotation. It's not the reinforcement bar itself. So you follow that particular arrow, moving with it up to this point. Okay, so the part where there is this particular mark, at times it might be a dot, a very thick dot, and then you also notice the thicknesses of those particular line work. So moving this way, the bar is at this point. I hope you can see that as well. So that is the reinforcement bar, the one that is perpendicular to the arrow. Please don't forget that. So it means our reinforcement bar is this one here, the one that is going all the way internally. Okay, there are 14 of them and they are T10. Okay, so as we have done before, get to your plan, get that particular length. According to this, that length is 3.6 meters. Okay, 3.6 meters goes end to end, which this particular reinforcement bar is not going, but it leaves a very smaller space. So we can assume that it goes the entire stretch. Once you have that, then the length, we've seen it as 3.6 meters. Okay, how many pieces of them do we have? That is the next question. They are 14. So we multiply that by 14. Okay, you go along within the same particular plan. Just check if at all there is another reinforcement bar that is also marked as bar mark 3, because all bars that are marked the same, having the same mark, are normally given that mark because they are of the same length. So 3 is done, just tick. Then I move to 4. I can see 4 here, the one I was using to give an elaboration. bar mark 4 is here. Okay, up to now you should be able to notice or you should be able to know where the reinforcement bar itself is now according to the annotation rules. Well, so bar mark number 4 is here. This is the arrow. So you follow that arrow along. So you follow that arrow all the way up to here. Okay. So this is where I found the reinforcement bar. So let me just zoom it out again. So this one goes all this way. It comes up to this point. Okay. So from this point, we have the arrow. We have the reinforcement bar perpendicular to the arrow that is used to annotate. Okay, so that is quite clear. The reinforcement type size is D10. So I should have this under D10s. Okay, so under the D10s, it's there are 16 of them, but I need to get the length first. Okay, so the length, it's along the width of the plan, and that dimension is 1.6. Okay, so from the 1.6, I take 1.6, I will multiply that by the number of the reinforcement bars. There are 16 of them. I'll multiply that by 16. Then I will just check if at all there is another bar mark 4 within this plan, but I can't see, so it means there isn't another one. Okay, so up to that point, I have done bar mark 4. Okay, I'm going straight to bar mark 5. Bar mark 5 is of T10 in size. So I will add that particular dimension to my summations for length for the bar mark D10. Okay, so let me proceed. I get the length, and that one is surely got through following the arrow. Follow the arrow until you find the point where there is a dark line, okay, a thicker line than the arrow itself, perpendicular to it, okay, and in many cases there is this mark or can have a dot, okay, depending on the mode of annotation that the engineer has adopted. So I will take this is 31 T10. I move through it here. So this bar is the same length as the one that we have talked about, the 1.6. Okay, so this case it's going to be 1.6 meters. You will multiply that by the number. How many of them? We have 31 pieces, okay, of that bar. So I have done bar 5. That is done. So the one I'm left with is bar number 6. Bar mark number 6 is T10 again, okay? It's T10. I need to get the particular reinforcement bar itself. So along it, I come this way. I move along it straight up to here. This is where there's perpendicular line on it, okay? On the perpendicular line, there is the reinforcement bar here. And that length, we'll take it equivalent to the one that is moving the entire stretch, okay? And the entire stretch internally is 3.6 meters, okay? So there is no harm. There's a slight difference in terms of the assumption that we are taking it in full, but in real sense it's not, though that difference is quite minimal, so it shouldn't worry you at all. So not unless the difference is quite big, then you can always rely to take the exact lengths. And as a QS, you have to remember that you'd rather be slightly higher than being less in terms of your estimation. So always remember that concept. So in this case, the reinforcement bar at bar number 6, we get to D10. Okay, we add this. Let's add it here. And when we do, like the exact length we've said, we'll take the 3.6 meters. We'll multiply that by 17 because there are 17 in number according to this annotation. All right, so once we have that, So bar mark number 6 is complete. Okay, so 1, 1, 2, 1, 1, 2, 3, 4, 5. All of them are done. Oh, I can see there's another one still left here. This is bar mark number 2. So bar mark number 2, we have one that was not done. So you can see the essence of marking or just striking off the items that you've already dealt with so that you don't forget others along the way. So this one is number 2. And number 2 is T16. T16, the dimension was, it's the one that we gave 1.2 times 2 and so on. So just go to this one, 1.2. So this is it. So multiply that times 2. You can see 17 here, 17 to 16, so that we have the complete length. Okay, so for the base slab, we already have the length, so we can make this to be the length in meters. Okay, make that length in meters, and then just on the side, let's make it kgs. Okay, so we need to convert this total length into kgs. So what you'll do, take that length, then you multiply by the diameter squared. So the diameter is 10 millimeters. So multiply by 10 times another 10, then you divide by 162. Okay, so the 10 is the diameter, you square it. 162 is a constant for the conversion of the reinforcement from lengths to kgs. That is it. So we have our kgs to be 115.3. Okay, using the same concept, take the length of the D16, then you'll multiply it by the diameter squared. Diameter times diameter, divide by 162. Okay, that one gives us another 328. So we have dealt with the slab in entirety in terms of the reinforcement. So we'll repeat the same for the next of the other elements. But for now, that brings us to the end of our coverage, because we just wanted to focus mainly on that base slab until it's completed. Thank you very much for watching up to this point, and I hope I was elaborate enough and the video has been of help to you. If you find it helpful, please make a subscription to the channel to help us reach more people, to share the knowledge that we passionately would like to share. Leave a comment if you liked it, and also don't hesitate to share. And also I would emphasize that please you would have it I would request you that you can also join the membership channel, because it also supports the channel as well. Thank you very much. Stay tuned for more upcoming videos, even to completion of the rest, like for the walls is going to be in the next video, and also for the cover slab. Those are all of which are different, and you won't wish to miss them. Thank you very much. Have a great time. Till we meet again in our next session. Bye bye.